our addition formula from yesterday here at the beginning. So we're going to start looking at things called multiple angles. So 7-4 is all about multiple angles. So we're going to start with double angles. And what we're going to do here is we're going to think about the sine of 2u as our first one here. But what we're going to do is we're going to look at it as, ooh, that's not the pen I wanted. Try that again. There we go. The sine of u plus u. We agree that means the same thing? Sine of 2u is the same thing as sine of u plus u. Now we're going to use the addition formula from yesterday. Where we take our sine addition and we're going to rewrite this using that sine addition. So sine of the first one, cosine of the second one, plus, because sine keeps the sign the same, sine of the second, cosine of the first. Can we simplify that? Yeah. 2 sine u cosine u. So whenever we have, ooh, pen, stop being a jerk. Sine of 2u, it means the exact same thing as 2 sine u cosine u. So when we get to the page where I give you all the formulas, it's going to be these. We're deriving all the formulas right now. So they're all based off of those same addition and subtraction formulas we worked with yesterday. The addition and subtraction. Okay, 2 days ago. Sorry. I can't remember which day we did what. Brain is braining. Okay, so when we get to the page where we have all the formulas, it's going to have sine of 2u equals this, and we just proved it. And I just left a gap in there, and that's going to bother me. There we go. So we're going to do the same thing with cosine. We're going to follow our cosine addition formula. We can rewrite this as cosine of u plus u. So when we rewrite that using our addition formula, we're going to have cosine u minus, because cosine keeps itself together, but it changes the sign, sine u. Right. A is u and b is u. So when we simplify this, we could rewrite this as cosine squared u minus sine squared u. So we can rewrite, that's not a highlighter. There we go. Cosine of 2u as cosine squared u minus sine squared u. We also know a lot of things about cosine squared and sine squared because that's one of our Pythagorean identities. So if we wanted to, and we do, we could switch cosine squared out to be 1 minus sine squared from that Pythagorean. Minus sine squared. So we could also write this as 1 minus 2 sine squared u. So I can get cosine in terms of just sine. This means the exact same thing. We could also go do the same thing with the sine. So cosine actually has 3 different ways we can write it.
Can we just leave it like that?
Well, we're going to write all 3 of them on the next dang page anyway, so we're deriving it. There's going to be times when we want each one of them, but we could also, because trig's weird, cosine squared u minus sine squared u. We could also swap this one out to be 1 minus cosine squared u. Oh, I hate a discordant truck beep like that. That bothers me. Makes my brain hurt. So watch out for this double sine situation because we wind up with 2 cosine squared u minus 1.
So you can do it either or.
There's 3 different ways to do the cosine. All 3 of these things are the same as cosine 2u. All 3 of them. And I have it typed up all pretty on the next slide so you can see them all without all the gobbledygook in between. But this is how they get them as opposed to just me giving you the formula and you going, yes, ma'am, we memorize. This is where they're coming from. Because this class has a lot of memorization, and if we don't have to like just straight up flashcard memorize it, it's a little bit easier to understand where they come from. All right, so our last one is tangent. Tangent's a little bit grosser because it has that fraction, but we can do it because we're awesome like that. Let me get a different color. There we go. Rah, pen. So we're going to, again, do this as the tangent of u plus u. So using our tangent addition, we have our fraction. Tangent of u plus the tangent of u over 1 minus the product of tan u, tan u.
Wait,
What's up?
on the last one?
Yep.
How did you get 1 minus 2 sine squared u?
1 minus 2 sine squared u. We replaced the cosine squared with 1 minus sine squared. And then these parentheses aren't actually doing anything. So I combine my like terms. Okay. I'm just going to put them back so we have them there for the notes. But it's all subtraction, so it's not, those parentheses aren't actually doing anything, so we just combine our like terms. No, good question, good question. Okay, so when we simplify this, I've got tangent of u plus tangent of u. So we have 2 tangents of u over 1 minus tangent squared of u. So again, we can rewrite tangent of 2u, bless you, as this piece. Oh, that's too dark. I don't like that. There we go. Oh, that's much better. Much easier to read that. That was just a little dark. Okay, so these are the double angle formulas. Like, these are formulas. If you Google double angle formulas, we just found them and built them. These are them. So in the book, they have them all typed out, all pertified. And I'm going to show them to you, but you just wrote them down. So if you like them slightly more organized, feel free. But these are what we just found. These are the double angle formulas. And we're going to be using these a bunch to find, like they're going to ask us to find sine of 2u's. These are what we just wrote down. It's just typed up all nice. And so you don't have to read my handwriting or your handwriting. But these come in a table in the book. Like, these are on reference pages places. Not for us, but other places. Okay, yep.
Cosine, you could ask for like all three.
You can use whichever one makes most sense. So sometimes we're going to be asked to find cosine of 2u, and they're only going to give us sine. Sometimes they're going to ask us for cosine of 2u, and they might only give us cosine. And so we don't have to switch it around. We can use any of these because they all mean the same thing. So when we're working with them, it's just a matter of which one makes their life easier. You can do everything from this one if you want to. Like, you can do them from either one of them. You don't have to use all three, but you can use any of the three. Okay, so we're going to practice with these, I promise. And they give us these problems in what feels like a overcomplicated way, because naturally they do. That's just the world we live in and the textbook they've chosen. They make stuff way more complicated than they need to, because choices. We love it. So when they give us problems, I feel like most people have stopped writing. Oh no, we still got a couple writing. I'm gonna give you a second. Keep writing. We good on time today. Like, I think we might have time today. Okay. Everybody else looks like they're doodling. They're gonna give us problems like this. So we're given secant of x. We're told something about x, and we're asked to find a double angle. We won't always be given secant, but we're going to be given some trig function, told something about our angle, and asked to find a double angle. So what we're going to do is we're going to look at this and figure out what the heck they're trying to get us to notice. So I tend to start here. This piece, pi over 2 is less than x is less than pi. It's going to tell us what quadrant we're in. What quadrant are we going to be in? 2. We're going to be in quadrant 2. Because remember, pi over 2 is our 90, and pi is our 180. So it's in that quadrant, between 90 and 180. So if we were to give ourselves a sketch of this angle, we know it's somewhere in quadrant 2. So we're going to think about this angle. We know secant. Secant is the reciprocal of cosine, which means, if we think about this in terms of our triangle, cosine is adjacent over hypotenuse, right? So this is the same thing as hypotenuse over adjacent, since it's the reciprocal. See all those pieces? So if we think about our angle being a triangle, I know that this side is 5 and this side is 13. Oops, that was meant to be laser pointing. Which of these sides is going to be negative? The cosine. The 5 is going to be negative. We're in quadrant 2. My x's are going to be negative, my y's are going to be positive. So how can we figure out the length of this side? Pythagorean theorem. We know negative 5 squared plus something squared equals 13 squared. That's my hypotenuse. So let's figure out what that other side is. 5 squared is 25. 13 squared is 169. So b squared equals what? 144. Whoa, what is that for? Try that again. There we go. That looks like a number. So what is B going to be? 12. So this missing side is 12. The reason we care is because if we go back to our sine formula for sine of 2x, we need to know both cosine and sine. So we need to have all the values in order to fill in our formula. Because when we do sine of 2x, our formula says that that's 2 sine of x cosine of x. So we're going to fill in the values. It's going to be 2. What is sine of this angle? 12 over 13. What is cosine of this angle? Negative 5 over 13. So can we simplify this? We're going to have 2 times 12 times negative 5 as our numerator. What is 2 times 12 times negative 5? Negative 120. And 13 times 13, 169. So the sine of 2x is negative 120 over 69. That's our answer. Questions on that one? This guy?
Like, yeah, why would you do that?
We did that because 2 sine u cosine u. Okay, so it's using the double angle formula. We just, since it was x, we just switched them to x's. Okay, we're going to practice some more, just like this. This is where we're living in today. We're going to live with these kinds of problems in our double angle formulas, just like these. We're going to do a bunch like this, as many as we can. So here's our next one. So we're given sine of theta is 1/4. And that 0 is less than theta, which is less than pi over 2. And we're asked to find cosine of 2 theta. So I tend to start here. What quadrant are we in? 1, quadrant 1, which means my sines and my cosines, everybody's positive. We love that. Nobody's negative. Huzzah. We're asked to find cosine of 2 theta, and we're given sine. If we look at our formulas, if I know sine, do I need to figure out any other information? No. We can just use that one to figure out cosine of 2 theta without having to draw a triangle or figuring out any other pieces of the triangle. So we're going to use the sines only version of cosine 2 theta, which is our 1 minus 2 sine squared theta. That's the formula. So we're going to do 1 minus 2 times our sine theta is 1/4 squared. One minus. What is 1/4 squared? 1/16. 1/16 times 2. 2/16. 1/8. What's 1 minus 1/8? 7/8. So cosine of 2 theta is 7/8. So once we get the hang of these formulas, they look really weird, but they're just kind of substitution. Like, they're not the worst. They're not the worst. We've had worse than this. Okay, so once we get the vibe of these don't suck too bad. Eventually. Wednesday. Sorry, I had to look at the page. I don't remember off the top of my head. Oh, I could have flipped this way and looked that way. Yeah, Wednesday the 6th is our next quiz. And it'll be over the adding and subtracting, the doubles, and what we do tomorrow, which will be halves. So it's very similar vibe, but instead of it being 2 theta, it'll be theta over 2. I have not graded a single one yet. It has gone on several field trips with me. They have been in my backpack since you took them, but I have not graded a single one of them. So I have no idea. They're just going on field trips with me and just carrying them around the school. The quizzes that y'all took. The one you guys took the other day. I haven't graded them yet. That's what we're talking about.
What other day?
Tuesday. The one you took on Tuesday. Yes, 2 days ago. The quiz you took 2 days ago. I haven't graded them yet. I've just been carrying them around. As much as I would love to do that, you would get very grumpy at me for that choice. If I just gave everybody 100% on it. I mean. All right, let's look at this one. So we've got cosine theta is 1/5. And we've got 3 pi over 2 is less than theta, which is less than 2 pi. So what quadrant are we in? 4. So if we draw this angle, we know it's somewhere down here. And I just tend to draw it acute with the x-axis just because it makes it easy for us to do stuff with. So if we know cosine is 1/5, that's our adjacent over hypotenuse. So if I go over to my little triangle, we have our adjacent is 1, and my hypotenuse is 5. We can find our third side using our Pythagorean theorem. That guy comes back so many times. So we're going to have our 1 squared plus something squared equals 5 squared. 1 plus b squared equals 20. I made very interesting parentheses choices, but you know what? We're just kind of rocking with it. Put parentheses around my b and not around my 5. It's a choice. We're just going to roll with it. It's not making any difference anyway, but it was a choice. So what does b squared equal? 24. So what's b equal? Where'd you get 21 from? I square root of 24, which we can simplify. So perfect square inside there. 4, so we have 2 square root of 6. And I heard a couple of people notice it. Is it going to be positive or negative? Negative. Negative 2 square root of 6. That is the part that I recommend the sketch for. It really helps us remember which sign these things are going to be. If you remember that Q4 means we're going to have a positive cosine and a negative sign, you don't have to do the sketch. The sketch is not a part of that. It just really visually helps us make sure we don't forget a sign. This is not a you have to do it thing. This is very handy for figuring this out and remembering our signs. Okay? But if you got the signs like down pat, more power to you. It's not work for my brain. All right, so we're going to use our sine of 2 theta formula to get our double angle. So sine of 2 theta, that's our 2 sine theta cosine theta. So we're going to have 2 times, what is the sine of our angle? Negative, hope that didn't myself speak. 2 square root of 6 over 5. Gross. What is there? What's the cosine of our angle? 1/5. Good way to double check because it's what was given to us right here too. So when we simplify this, what are we going to have? 2 times negative 2 square root of 6 times 1. Negative 4 square root of 6 over, what's our denominator? 25. So our sine of 2 theta equals that. Was that I understand or I don't understand? I couldn't tell. I only have 2 more of these down for us. We have 15 minutes. We have not been taking that long on each of these, so we should be all right on time-wise. Okay? 2 more. And they're not particularly worse. All right, so we're given cosine is negative 2 over 13. That pi over 2 is less than my angle, which is less than pi, and we're asked to find the double angle of cosine. So what quadrant are we in here? If we're between pi over 2 and pi. 2. We don't really need it on this one, but it's good practice for us to identify them anyway. Because since we're asked for cosine, and we're given cosine, don't we have a cosine formula that only uses cosines? Then we don't need to even draw the triangle. Like, we have enough information from here to just go. Because we can write cosine of 2x using our just cosine formula, which was 2 cosine squared x minus 1. We know cosine of x. It's that guy. So we can take this formula and make this 2 times negative 2 over 13 squared minus 1. What is negative 2 over 13 squared? Super close. Positive 4 over 169. Don't get caught up in those signs. So 4 over 169 times 2. 8 over 169. Minus 1. Goodness, somebody's group chat's blowing up. Because your phone now vibrates. Bzzz. 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 So when in doubt on something like this, get to common denominators. 8 minus 169 over 169. Negative 161 over 169. Okay. One last one for the day. Because the one we haven't actually done yet. Oh, snap, fractiony goodness. Tangent. So in our tangent formula, we need tangent. So we need to know tangent of theta. So for show, we're going to draw our whole triangle here. So what quadrant are we in here? If pi is less than our theta, which is less than 3 pi over 2. We're in quadrant 3. So I'm going to draw my little triangle in quadrant 3. So we're down over here. And we're going to see what pieces we know. We know sine is negative 12 over 13. So we know our hypotenuse is 13. And our opposite sine is negative 12. Since we need tangent, we do need to know the other leg. So let's use our bestest friend, Pythagorean theorem. We're going to have our negative 12 squared plus b squared equals 13 squared. So that's 144 plus something squared equals 169. So what's b squared? 25. So what's b? 5. So what's the length of this side? Negative 5. So then what's tangent of that angle? What's tangent of theta? Yeah. So negative 12 over negative 5, which we then notice that our negatives cancel out. So we just have 12 over 5. Because if you look at our tangent formula, the only thing in it is tangents. So it helps to have the tangent so we don't got to figure it out a gazillion times. So we're going to take our tangent to theta formula. So tangent of 2 theta equals, we got our fractiony goodness. 2 tangent theta over 1 minus tangent squared theta. And we are going to have fractions on fractions of Gloria. So I'm going to come down here, and I'm going to probably work sideways just so I don't run out of space. So we're going to have 2 times our tangent, which is 12 over 5. What's up, guys? You good? Okay, just chill. This is the last one. Huh? I think you've gone on a tangent. That's for sure. I don't think you're talking about tangent. You just took a tangent. So, homonyms are fun. What was that? Okay, so we're filling in the pieces we know. And then we're going to come through and simplify this because holy fraction upon fractions, guys. So I'm going to simplify numerator and denominator so that we can multiply by reciprocals. So my numerator, 2 times 12 over 5, 24 over 5. We have 12 over 5 squared. 144 over 25. So we have 1 minus 144 over 25. So what's 1 minus 144 over 25? Negative 119 over 25. And now we can make this not be fractions upon fractions. We can multiply by the reciprocal. So we're going to have 24 over 5 times 25 over negative 119. And we need to simplify this. You can do that, but then you're going to be simplifying that big old guy. The 5s. So we have 24 times 5, which is significantly less gross. 120 over negative 119. So it's the same kind of process. Tangent just feels grosser because it's fractions of fractions. Okay? So tangent of 2 theta equals that guy. Okay? So tomorrow we're going to keep working with these, but in a slightly different way. Instead of them being doubles, they're going to be halves. All right? So...
Can you go back?
Yes, I can. I just like to get I have to actually get the another page up there every now and then before the end of the period. Just as a reminder, I know most of you guys have, or at least about half of you guys have, this is the challenge problem. You get an actual cookie for trying it. I have them over there. Tomorrow's the last day for the challenge problem. It will change, mostly because I want to take the cookies home because I'm going to eat the rest of them. So if you want a cookie, you got to turn it in by tomorrow. Because I ain't keeping the cookies over the weekend. They're going to go in my face. Yeah. Everything. Putting the thing up. Huzzah. Boop, boop. What's up? Right. Yeah. Yes. And I have marked down that you do get your cookie. Give me. Here's your cookie. Thank you. This is my super high tech. I'm not touching everybody's cookie piece of paper. Oh my gosh, the fact that she didn't send one for me drives me nuts every single time I open it because they smell so good.